Here's the lesson for section 4.1, solving simple equations. The first way I'm going to show you how to solve an equation is by using the balance method. So what do I mean when I say the balance method? I mean you have to always make sure that you're keeping your equations balanced when you're solving for a variable. So before I go ahead and show you how to solve an equation using the balance method, I'm just going to show you a quick demonstration of why the balance method works. I'm going to show you using an equation that doesn't have any variables, so we can easily see what's happening. So if you read here, an equation is still true if you apply identical operations to both sides. So as long as you keep it balanced by doing the same thing to both sides. So let's take a look at that. So here's an equation, 5 equals 5. Everyone knows that to be true. As long as I can apply any operation I want, and this equation will stay true, as long as I apply the same operation to both sides of the equation. For example, I'll show you a couple of basic examples. If I add 1 to both sides of this equation, I've added 1 to the left, I've added 1 to the right. So now on the left I have 5 plus 1, which is 6, and on the right I have 5 plus 1, which is 6. And we know that 6 is equal to 6, so this equation is still true. Okay? As long as we have balanced it out by doing the same thing to both sides of the equation. And this example here, if I multiply both sides of the equation by 2, I get 10 equals 10. Therefore, this equation is still true as well, since I multiplied both sides by 2. Okay, so keeping that in mind, let's look at an equation that has a variable, so it has an unknown value, and we want to figure out what that unknown value actually is equal to. So just a little note here, when solving an equation, the goal of solving an equation is to isolate the variable. So we want to get x all by itself on one side of the equation so that we can figure out what x is actually equal to. So keeping in mind that we want to have x all by itself on one side of the equation, I don't want this plus 4 here beside it. So how can I get rid of 4? Well, it would be nice if I could just subtract 4 and it was gone. I can do that as long as I remember to balance my equation. So if I subtract 4, so I've subtracted 4 so that this 4 will be gone, I also have to subtract 4 from the right side to keep that equation balanced. So if I do that, if I subtract 4 from both sides, what I'm left with on the left side is just x, because 4 minus 4 is 0. And what I'm left with on the right side of the equation is 8, because 12 minus 4 is 8. So that tells me that x is equal to 8. And that makes sense, because if x is equal to 8, so if x is equal to 8, 8 plus 4 is 12. So 8 is the value of x that makes this equation true. And I determined that by isolating x, getting x all by itself on one side of the equation, and the other side of the equation told me what x is equal to. So let's do a couple examples. So I have x minus 2 equals 8. I want x all by itself on one side of the equation so I can figure out what value of x makes this equation true. What I have to do, I need to get rid of this minus 2 that's beside that. If I could add 2, it would be gone. Negative 2 plus 2 is 0. So if I add 2 to the left, I also have to add 2 to the right to keep this equation balanced. So you see how I did the exact same operation to both sides of the equation. I added 2 to both sides of the equation. Let's go ahead and solve now. So I have x minus 2 plus 2. And negative 2 plus 2 is 0. So that's gone. On the right side of the equation, I have 8 plus 2, which I know is 10. And then just do a quick check and make sure that's the right answer. So when I solved the equation, it told me that x is equal to 10. So let's check. Is 10 the value for x that would make this equation true? So if x was 10, would this equation be true? 10 minus 2 is 8. Good. So 8 would equal 8. 10 is the correct answer for that. So remember, you can always check your answer for these questions just by plugging your answer back into your original equation and making sure that the left side of the equation is equal to the right side of the equation. So 10 minus 2 would be on the left, and that equals 8. And the right side of the equation is 8 as well. So the left side would be equal to the right side. Let's solve this equation here. I have x plus 7 equals 5. To determine the value of x that makes this equation true, I must get x all by itself. So what I need to do is I need to get rid of this positive 7. I can do that by subtracting 7. But if I subtract 7 from the left side, I also need to subtract 7 from the right side. You'll see how I did the exact same operation. I subtracted 7 from both sides of the equation. That kept it balanced. So this equation is still, so the left side is still equal to the right side because I did the same operation to both sides. Let's simplify this now. 7 minus 7 is 0, so all I'm left with on the left is x. 5 minus 7 is negative 2. So it tells me that x is equal to negative 2. Let me do a quick check and make sure that's right. If I plug in negative 2 for x, I have negative 2 plus 7. Is that equal to 5? Yes, negative 2 plus 7 is 5, so 5 equals 5. Therefore, the left side equals the right side, so that is the correct answer. X equals negative 2 is the correct answer. Okay. You can probably perform that check mentally without writing it out, but for more complicated questions, you might want to actually substitute it in and do the math to make sure that you've solved the question right. Okay. Negative 4 plus x equals negative 1. How could I get rid of this negative 4? Well, the opposite of negative 4 is positive 4. And you'll notice back here, I'm always doing the opposite operation. So if I have x minus 2, the opposite of minusing 2 is adding 2, and that's what got rid of that minus 2. Over here I have x plus 7. To get rid of that plus 7, the opposite of adding 7 is minusing 7. So that's what I did to get rid of the 7. So over here, I have a negative 4. The opposite of negative 4 is positive 4. So let's add 4. So I have negative 4 plus 4 plus x. So that'll eliminate the 4 from the left side. Then I'll have x all by itself. So I must also add 4 to the right side. So I applied this plus 4 to both sides of the equation, so it is still balanced. These 4's will eliminate. Negative 4 plus 4 is 0, so all I'm left with is x. On the right side, negative 1 plus 4 is 3, so x equals 3. And you can plug that back in and check. If x is 3, does the left side of the equation equal the right side of the equation? Negative 4 plus 3 is negative 1, and negative 1 equals negative 1, so that's the correct answer. This one, so I have 10 plus x equals 5. To get rid of this positive 10, I must subtract 10. So 10 minus 10 plus x. But I can't just subtract 10 from the left side, I also have to subtract 10 from the right side to keep it balanced. 10 minus 10, those 10's are gone, so all I'm left with is an x on the left. On the right, 5 minus 10 is negative 5. So the solution to this equation is x equals negative 5. Negative 5 is the value of x that makes this equation true. 10 plus negative 5, or 10 minus 5, is 5. So left side equals right side. Alright, what I would suggest you do now, just pause the video quickly and try these questions. That way you can make sure you understand what we've been doing. So pause now. Okay, hopefully you've had a chance to try them. Let me take them up with you quickly. I'll do a little bit less explanation this time. So I have x minus 7 equals 8. To get rid of this minus 7, I do the opposite of minusing 7, and that's adding 7. So x minus 7, I'm going to add 7 to get rid of that. And equals 8 plus 7. Negative 7 plus 7 is 0, so that's gone. I'm left with x equals 8 plus 7 is 15. So my solution to that equation is x equals 15. And 15 minus 7 is 8, so that's the correct answer. This one, x plus 5 equals 5. Isolate the x by getting rid of this positive 5. The opposite of adding 5 is subtracting 5. So I'm going to subtract 5 to cancel out that 5. But I must also subtract 5 from the other side to keep it balanced. 5 minus 5 is 0, so all I'm left with is x. On the right side, 5 minus 5 is 0, so I'm left with 0. So the solution to this equation is x equals 0. 0 plus 5 is 5, so that's the correct answer to that equation. Okay, so like I've been saying, hopefully you're starting to notice that the trick to isolating a variable is just to apply the opposite operation. So what we'll hopefully get in the habit of, hopefully every time you won't have to write out plus 5 minus 5, for example, on this side of the equation, you'll know that those are just going to cancel. So what we're going to want to do, I'm going to rewrite the question. So I have x plus 5 equals 5. What we want to do, we want to think of just moving a term to the other side of the equation by doing the opposite operation. So I'm going to move this plus 5 to the other side of the equation, and it's going to become minus 5. It's going to become the opposite of what it was on the other side of the equation. So to move something to the other side of the equation, just apply the opposite operation. So what I'm left with now that I moved this plus 5 to the right, so it's been moved to the right, what I'm left with is just the x on the left, and on the right I'm left with 5 minus 5. So if I was adding 5 on the left, when I move to the right, it becomes subtracting 5. Okay? So hopefully that makes sense, and if you go ahead and solve that, 5 minus 5 is 0. We're kind of essentially just skipping the step where we rewrite the minus 5 on this side of the equation because we know it's going to cancel out what we wanted to move. Okay. Hopefully that makes sense because we're going to use that from now on. So I have 3x equals 18. I don't want this 3 on the left side of the equation. I want to figure out what x is equal to, so I need x all by itself. So I need to move this 3 to the other side of the equation. I know to move something to the other side of the equation, I have to apply the opposite operation. Okay? So what I have right now is 3 times x equals 18. So to get this 3 away from the x, I must do the opposite operation. So I must do the opposite of 3 times x. The opposite of multiplication is division. So to move that 3 to the other side of the equation, I must divide it to the other side of the equation. So I'm going to be left with, that 3 is going to go to the other side, but it's going to become dividing by 3. So I'm left with x equals 6. If you want to keep using the balance method, which is completely fine, to get rid of this 3 from this side, you're going to have to think of opposite again. The opposite of multiplying x by 3 is dividing x by 3. So we'll have to do that. We'll divide x by 3, but then I must also do the same operation to the other side of the equation. So I must divide the other side of the equation by 3. And then what's going to happen is we have a 3 divided by a 3 on the left side. Those are going to cancel to equal 1. So I'm left with 1x equals 18 divided by 3 is 6. So think of it either way. I like to think of just moving it to the other side so I don't have to show this canceling every time. But it's up to you. Okay. So number 8. If I have x divided by 4 equals 3, I want x by itself, so I need to move this 4 to the other side of the equation by doing the opposite operation of what's happening right now. So I have x divided by 4. What's the opposite of dividing by 4? The opposite of division is multiplication. So to move this 4 to the other side of the equation, I must do the opposite of dividing by 4, and that is multiplying by 4. So to move this 4, I must multiply the other side of the equation by 4. And the x is now all by itself because I took this 4 and I moved it over here by multiplying by 4. Because that's the opposite of dividing by 4. So x equals 3 times 4, which is 12. And 12 divided by 4 is 3, so that's the correct answer to this equation. Okay, this one's a little trickier. I'll do this one for you. You can try this one right now if you want. Just pause it. Okay, but for this one, think of negative x equals 9. Think of it as negative 1x equals 9. There's a couple ways you could think of this question. I'll show you both ways. So I have negative 1x equals 9. Remember, if you don't see a number in front of a variable, there's an invisible 1 there. So I have a negative 1x. Negative 1 times x. I want x all by itself. I can't have this negative in front of it if I want to solve for what value of x makes this equation true. So I need to move this negative 1 to the other side. So right now I have negative 1 times x. The opposite of multiplying x by negative 1 is dividing it by negative 1. So to move this negative 1 to the other side, I must divide it. So what I have is x equals 9 divided by negative 1. 9 divided by negative 1 is negative 9. So that's one way you could think of doing this question. Another way, so I have negative x equals 9 equals, what you could do, you always need to isolate the positive value of the variable. Okay, so I need x to be positive. To make x positive, I could just move it to the other side of the equation. So if I move the x to the other side, I'm left with nothing on the left. And on the right, I have 9 plus x. Now I need x to be by itself, so I need to move this 9 to the other side. So I have a plus 9 on this side. To bring it to the other side, I must subtract 9. So I'll have 0 minus 9 equals x, and 0 minus 9 is negative 9. So this equation tells me that x is equal to negative 9, and that's what I got here. So essentially all we did was we moved the negative x to the right, it became positive, moved the 9 from the right to the left, and it became negative. And I got x equals negative 9. So think of it either way. Either way, you'll get the same answer. Okay, number 10. So I have 5 times x equals 30. I want x by itself. So what I need to do is I need to move this 5 to the other side of the equation by doing the opposite operation of what is happening over here. So I'm multiplying x by 5. The opposite of multiplying x by 5 is dividing it by 5. So to move this 5 to the other side, I must divide by 5. So I have 30 divided by 5. 30 divided by 5 is 6. So x equals 6 is the answer to this equation. And 5 times 6 is 30. So the left side equals the right side. That's the correct answer. Over here, I have x divided by 7 equals 3. I want to get x all by itself, so I need to move this 7 to the other side of the equation. On the left side, x is being divided by 7. So to move this 7 to the other side, I must do the opposite operation. The opposite of dividing by 7 is multiplying by 7. So I get x equals 3 times 7. Therefore, x is 21. And that's the correct answer to this equation because 21 divided by 7 is 3. Make sure you just check mentally every time. Make sure that's the correct answer that you've solved for. Okay, next we're going to do some two-step equations. So, if on one side of the equation you have more than one term, the first thing you want to do is you want to isolate the term that has the variable. So I want to move the other term to the other side of the equation. I want to get the term with the variable all by itself. So I want to get this 5x all by itself first. Okay, so in order to do that, I need to subtract the 25 to the other side. So on the left side of the equation, I'm adding 25. On the other side of the equation, that's going to become subtracting 25 because the opposite of adding 25 is subtracting 25. So I'll have 5x equals 500 minus 25. Okay. Now let's simplify that. 5x equals 475. Now what I have is 5 times x equals 475. I need to isolate the x now. Okay, now that I have the term with the x all by itself, now I want to actually get the x all by itself by moving this 5 to the other side. So right now I have 5 times x equals 475. So what I'm going to do now is I want to move this 5 by doing the opposite of multiplying by 5. The opposite of multiplying by 5 is dividing by 5. So what I have is x equals 475 divided by 5. And 475 divided by 5 gives me 95. And that's the solution to this equation here. You could plug it back in and do the quick check. 5 times 95. You might want to write this one out and actually solve it to make sure the left side equals the right side. I'll do that for you if you'd like. So plug in 95 for x and make sure that the equation stays balanced. Okay, make sure that it stays true. Make sure the left side still equals the right side. So 5 times 95 plus 25 equals 500. So make sure this left side of the equation equals 500. 5 times 95 is 475. And then 475 plus 25 is 500. So 500 equals 500. So the left side equals the right side. So once again, if you have an equation that requires more than one step for isolating the variable, isolate the term that involves the variable first, and then isolate the variable itself. So essentially what we did is you could think of it almost as performing BEDMAS in reverse. We did any adding and subtracting we had to do first. So we subtracted this 25 first, and then we did the multiplying or dividing that we had to do. So we did the subtraction first, and then we divided the 5 over. Okay, so we kind of did BEDMAS in reverse thing. So you can think of it that way if you want, just as long as you know you're isolating the term that has the variable first. So isolate the 5x first, and then isolate the x. Okay, so let's do this question. So a little reminder here, remember, isolate the variable term first. So I want to isolate this 2x first. So I have 2x minus 7 equals 9. I need to solve for what value of x makes this equation true. In order to do that, I'm going to first isolate 2x by moving that 7 to the other side. The opposite of subtracting 7 is adding 7. So I'm left with 2x equals 9 plus 7. 2x, therefore, equals 16. Now that I've isolated the term that has the variable, now I'm actually going to isolate the variable. So I have 2 times x. The opposite of multiplying by 2 is dividing by 2. So to bring it to the other side, I'm going to divide by 2. And what I'm left with is x equals 16 over 2. And I'll write my answer over here. 16 over 2 is 8. And just quickly check that answer. Make sure if x is 8, this equation is true. 2 times 8 is 16. 16 minus 7 is 9. And on the right side of the equation, I have a 9. So left side equals right side. That's the correct answer. 13. So I have x over 2 plus 4 equals 20. Once again, if it's a multi-step equation, isolate the term that has the variable first. So I want to isolate this term first. In order to do that, I need to move this plus 4 to the other side. The opposite of adding 4 is subtracting 4. So to bring it to the other side, I must subtract 4. So I have x over 2 equals 20 minus 4. And I'll simplify the right side of that equation. 20 minus 4 is 16. Now I want to bring this 2 to the other side of the equation because I want to get x all by itself now. Okay? So the opposite of dividing by 2, if I bring this to the other side, is multiplying by 2. So x is equal to 16 times 2. And 16 times 2 is 32. So x equals 32. And then let's check and make sure that's the correct answer to this question. Plug in 32 for x. 32 divided by 2 is 16. 16 plus 4 is 20. So 20 equals 20. So that's the correct answer. 14. So I put this one in here just to remind us that having a fraction answer is perfectly valid. So let's take a look. I have 16 times x plus 3 equals 15. Step number 1, remember, multi-step equation, always isolate the term that has the variable. Okay, so that's the first step. Get this 16x all by itself by moving this plus 3 to the other side. The opposite of adding by 3, or adding 3, is subtracting 3. So to move this 3 to the other side, I must subtract 3 on the other side. So I have 16x equals 15 minus 3. Therefore, 16x equals 12. Now I need to get the x all by itself by moving the 16 to the other side. So right now I'm multiplying x by 16. The opposite of multiplying by 16 is dividing by 16. So to bring it to the other side, I must divide by 16. So I have x equals 12 over 16. And let's put this into simplest terms. 12 over 16, what goes into 12 and 16? 4 does. So divide the top and the bottom by 4. Divided by 4. So divide the top and the bottom by 4 because 4 goes into both of those. 12 divided by 4 is 3. 16 divided by 4 is 4. So 12 over 16 is equal to 3 over 4. And that's our final answer for this one. And you can plug this back into your equation to make sure it's true if you would like. I'll do that for us. For this one, you might want to actually write it out and do the math. So let's check if x is 3 over 4, does the left side equal the right side? So I have 16. So I'll kind of separate this here. I have 16 times 3 over 4 plus 3 equals 15. Let's check and make sure that's the right answer. So I have 16 times 3 over 4. So I have 16 divided by 4. That's going to simplify to 4. So what I have is 4 times 3 plus 3 equals 15. 4 times 3 is 12. And 12 plus 3 is 15. So 15 equals 15. The left side equals the right side. So that's the correct answer. 3 over 4 is the correct answer. If you get a fraction as an answer, it's probably a good idea to check and make sure that's what you're supposed to have. Okay, so I checked, and that is the value of x that makes the equation true. So before moving on to the worksheet for this section, make sure you can get the correct answer to this question. So pause it now and try it. Okay, now I'll take it up for you. So remember, step number 1, isolate the term that has the variable. So I'm going to isolate the 2x over 3 by moving the plus 7 to the other side. The opposite of adding 7 is subtracting 7. So what I'm going to have is 2x over 3 equals 15 minus 7. Let's simplify. 2x over 3 equals 15 minus 7. 15 minus 7 is 8. Okay, so now I have 2x divided by 3 equals 8. Let's isolate this 2x now by moving this 3 to the other side. So right now on the left side, I'm dividing by 3. The opposite of dividing by 3 is multiplying by 3. So to bring it to the right side, I must multiply by 3. So I have 2x equals 8 times 3. Therefore, 2x equals 24. Now, let's isolate the x itself. So, to isolate the x, I must move this 2 to the other side. Right now, I have 2 times x. The opposite of multiplying x by 2 is dividing x by 2. So, to bring the 2 to the other side, I must divide by 2. So, I have x equals 24 over 2. Therefore, x is 12. And if you plug this back into your equation, check if it's right. Check if when x equals 12, does the left side equal the right side? So 2 times 12 is 24. 24 divided by 3 is 8. 8 plus 7 is 15. So the left side equals the right side. This is the correct answer to that equation. Okay, here's just a summary of everything we went over for this lesson. So to solve an equation means to find the value of the variable that makes the statement true. To solve a one-step equation, isolate the variable by performing the opposite operation. In a two-step equation, isolate the variable term first. Okay, that's important. Isolate the variable term first, then isolate the variable. And like we did it for all of the questions, you can check a solution by substituting the root. Root, that's a synonym for solution. So substitute your solution back into the equation. Okay, and that's it. Make sure you try the worksheet on jensenmath.ca. Download it, try it out, and make sure you check your answers and let me know if you have any questions.